This is the asynchronous recording for Geometry 1A Week 4. This week we're going to discuss the triangle proportionality theorem, and that means we're going to try to understand this theorem and also solve some problems by applying this theorem. So let's dive into this. First of all, what is the triangle proportionality theorem? Well, the triangle proportionality theorem tells us that if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Again, if a line, and this is our line here, so looking at line DE, if we know that line DE is parallel to segment BC, then we know that it is dividing this side of the triangle and that side of the triangle proportionally. Now, we are not making any claims about congruency here. This is not the same thing as the mid-segment theorem, which we reviewed last week. Okay, so we're not saying that AD is congruent to DB. We're not saying that AE is congruent to EC, right? That is something related to the mid-segment theorem. And in order to claim that, we would need to know that D and E were midpoints on their respective line segments, and we don't know that. What we do know is that line segment DE is parallel to BC. So that's the only thing we're given. We're given that DE is parallel to BC, right? And that tells us, and obviously just from looking at it, we can see that DE is intersecting the other two sides of the triangle, right? So based on that, we can say that this line segment DE is dividing the sides proportionally. Okay, dividing the sides proportionally. So before we get into what exactly we mean by dividing the lines proportionally, I do want to look at a proof of this theorem, okay? Looking at the ways that proportionality happens will be something that we look at particularly when we do just a few number of practice problems. But for this week, I do want to focus on going over our proof of this theorem. Normally, I focus more on application and in practice problems. This week, you guys are a little more into the class. You're a little more familiar with proofs, and I think that the proof part is harder than the application, so let's keep our focus here for today. So we're trying to prove this theorem. So again, I'm given this triangle, and I know that my line XY is parallel to that third side of the triangle BC. And they want me to prove this particular proportionality. They want me to prove that if I take the measure of AY and I divide it by YC, then that would equal AX divided by XB. Okay? Again, AY over YC is equal to AX over XB. This is that proportionality that I am trying to prove. So notice that I'm not actually claiming that the two sides like AC and AB, I'm not claiming that those are equal or congruent or anything like that. I'm just saying the proportion or the ratio from the line segments created on each side of that triangle are equal. Again, that their ratio is equal. So how do I begin this proof? Well, remember that we always begin proofs with what we're given. So I know that line XY is parallel to line segment BC, and again, I know that because it was given to me, and that's always where we start. And then I even like to fill in kind of where I'm going. I feel like it helps me keep my eye on the prize. Okay. Now I can't fill in the reason yet because I don't really know what's going to lead me there, but I know that that's where I'm headed. So let's start with, with the information given, what can I really say, or what can lead me in this direction towards proving my proportionality? Well, if I look at the triangle, look at these interior angles. In particular, look at angle Y and angle C. Now I know that they've already marked on this diagram that they are congruent, but imagine that that's not even there. So angle Y and angle C, I'm going to claim that that angle Y and angle C are corresponding angles. And I'm writing this shorthand for space and time. When you do this on your end, please write out the full statement and full reason. And I'm going to claim this because of the definition of corresponding angles, which is that when two lines are crossed by another line, the transversal, the angles in the matching corners are corresponding angles. So I've got these two parallel lines, and that was given to me. I know that I've got these two parallel lines being crossed by AC, right? That means that the angles created are corresponding angles. They're kind of like angles in the matching corners, right? So I can see that these are corresponding angles, and I could say the same thing about angle X and angle B, right? I could say the same thing about angle X and angle B. Based on the definition of corresponding angles, which again, if we've got two lines that are crossed by some transversal, then I know that the angles in matching corners are corresponding angles. So I'm going to claim that angle X and angle B are corresponding angles, and again, because of the definition of corresponding angles. So what good does that do me? What good does knowing that those are corresponding angles do me? What can I claim next? Well, I can claim that they are congruent, right? I can claim that, let me change my color again just for fun. I can claim that angle Y is congruent to angle C, and I can claim that angle X is congruent to angle B because of my corresponding angle postulate, which tells me that if I've got these two parallel lines, oops, sorry about that. If I've got these two parallel lines cut by a transversal, then the corresponding angles that result are congruent. So again, this postulate is just telling me that given this situation, I've got these parallel lines cut by a transversal, my corresponding angles are congruent. Again, that's by the corresponding angle postulate. So now I've established that congruency. You can see it was already marked on the diagram. That was a bit sloppy. Normally we would look at this and not have those congruency lines marked on here. Anyway, okay. So now I've got congruency established with this angle Y and angle C, and angle X is congruent to angle B. What does that tell me about my triangles? So you can see the bigger triangle, the large triangle here, but you know, we've got the second triangle right here as well, right? I've got triangle AYX, but I've also got triangle ACB or ABC. What does my information about those corresponding angles being congruent tell me? Well, it tells me that, I think I'm going to change my color just so you can see it. It tells me that triangle ABC or ACB, however you want to name it, is congruent to, or excuse me, similar, not congruent, similar to triangle, we'll call it AYX. So I've got my small triangle, and I'm saying it's similar to triangle ACB or ABC. And again, that meaning that if I've got, and this is from my AA similarity postulate, and I'll write that out, my AA similarity postulate. And this tells me, sorry about that, guys, I don't know why that keeps happening. This tells me that AA similarity postulate tells me that if I've got these, triangles, sorry, let's get back to it, that was weird. There we go. If I've got these two triangles and I've established that two of the angles there are congruent, then I can say, okay, those must be similar angles because or similar triangles because I've established that two of the angles within those triangles are congruent. And that's what and notice that it's AA, angle, similarity postulate. That's what that postulate is telling me. So again, I know my slideshow went a little crazy there for a moment. I apologize. But I've now established that my big triangle and my little triangle are similar. Okay, let's move forward. So I've got these similar triangles. Where am I going to take it from here? Well, based on what I know about similar triangles, I can say that AC over AY equals AB over AX. I can say that AC over AY is equal to AB over AX. I'm claiming that proportion, and I'm allowed to claim that because I know that corresponding sides of similar angles are proportional. Again, corresponding sides of similar triangles are proportional. And again, please write this out longhand, just to kind of keep your notes more clear. All right, so I know that. Now, I know that AC over AY is equal to AB over AX. Here's where it gets a little fun, and this is where kind of the ingenuity comes into play. I'm going to use the segment addition postulate. I'm going to use the segment addition postulate, which tells me, for example, let's say I've got some line segment. I've got a point here, and a point here. And I don't want to use letters we're already using. So let's say I've got D, E, and F. So my segment addition postulate is telling me that if I've got this line segment DF and I know that E lies on my line segment, then I can say, well, DF would be the same thing as if I measured from D to E and then E to F. So again, if I've got a line segment DF and I know that E lies somewhere on that line segment, then I can say that the measure of my line segment DF, the whole thing, is equal to the sum of its parts. Okay, and I'm going to use that definition here to claim that AC is equal to AY plus YC, so that AC is equal to AY plus YC, and that AB is equal to AX, this guy here, plus XB. AX plus XB. And I think, again, this is one of those things that is sort of intuitive. When you look at the diagram, you could have said, well, yeah, I figured that if I added AX to XB, I would get AB. But you do need to have that segment addition postulate in order to actually make that claim. And again, I apologize about this presentation. It's been doing this to me all day. Okay, anyway, so I've got this segment addition postulate. Now, I'm kind of starting to get, if you look, I don't quite have anything that looks like this yet, but I do have some ratios going on. I have some equalities going on. So now it's a matter of kind of bridging from here to there. We're finally starting to see how this might come together. Okay, so looking back to this proportion, I had AC over AY equals AB over AX. And now I've got this stuff. How can I use this information and combine this information? Well, if I know that AC is equal to AY plus YC, can't I plug that in there? Can't I say that AY plus YC over AY, wouldn't that be an equivalent statement? And then couldn't I do the same thing if I know that AB is equal to AX plus XB? Couldn't I plug that in for AB? So couldn't I say that that is equal to AX plus XB over AX? Aren't I allowed to do that? And yeah, I'm allowed to do that because of the substitution property of equality. It says that I am allowed to make that claim. Okay. Now, let's continue here. So notice that I've got AY plus YC over AY equals AX plus XB over AX. Let's see. I think I can simplify this. So I've got this AY over AY, right? So I can rewrite this. For example, I've got AY plus YC over AY. Can't I separate that into AY over AY plus YC over AY? That's the same thing, right? Yeah, and I am allowed to do that. And notice that if I did that separation, I could then, AY over AY is just 1, right? That would be just 1. So I can rewrite AY plus YC over AY as 1 plus YC over AY. And I could do the same thing on the other side, right? So if I separated out AX over AX, that would be equal to 1. And then I would still have XB over AX. Okay, and that's just by division, by my division property. I'm allowed to do that. Okay. All right, so let's simplify this. I've got this expression. How could I simplify it? Well, imagine if I subtracted 1 from both sides. Those would just cross out, right? So now I could just have yc over ay equals xb over ax, right? And I'm allowed to do that just because of subtraction, right? Subtraction property of equality. If I subtract the same amount from both sides of the equation, it's still equivalent. So I've got yc over ay equals xb over ax. Now look how close I am to the end. What's the difference here? It looks like I've found this equality of these proportions, but they're the reciprocal of what I was looking for. So how can I get from, from my current step to the end? Well, if two ratios are equal, then their reciprocals must be equal, and that's my final step. If I want to flip this over, take the reciprocal of these to get to here, it looks like I had an extra line here. I'm now allowed to claim that ay over yc is equal to ax over xb, because if two ratios are equal, their reciprocals are equal. Okay, so since yc over ay equals xb over ax, I can take the reciprocals of these and preserve that relationship. Okay, and that is my proof for this triangle proportionality theorem, or in particular, this one proportion within that theorem. Now, again, I know my presentation kept going kind of wonky through that, and I apologize, but let's recap. We took our given information, what we knew about that parallel relationship between x, y, and b, c. We used that to establish similar triangles, right? We said, okay, well, since we have this parallel stuff, we know that we've got some corresponding angles. Since I've got two corresponding angles happening between the triangles, they must be similar. Then we kind of switched gears. We used the segment addition postulate, but we also said, well, since we've got these similar triangles, we do know some information about proportionality, right? And from there it was kind of a matter of just rearranging an equation. So I had this equation. We used some substitution, division, and subtraction to kind of manipulate it. Finally, we took a reciprocal to get what we want. Now, I don't expect you guys to memorize this proof or to have been able to kind of just come up with this on your own, but I do want you to understand it. So make sure you review this. I think the proof also exists in your course player. So either by reviewing this video, reviewing the information in your course player, please make sure that you do understand this proof for the triangle proportionality theorem. Now, I promised just some quick practice after this, so that's what we're going to do. We'll just do 2 quick practice problems involving the triangle proportionality theorem. We proved one proportionality relationship based on the theorem, but there are actually several. So if you look at this diagram, there are several proportionalities that result from the theorem. You can see I've got these line segments labeled A, B, C, D, and the two sides of the triangle J and K. This is assuming that you know that this line segment is parallel to this one. Okay, so you need to have that information given to you before you can start making claims about proportionality. But, and I'm just going to go through 2 of these. I don't think we need to go through all 6. We could say that if you take A, this length, and divide it by J, that should give you the same measure as if you take C and divide it by K. Let me change colors. We'll look at another one. If you compare A over C, you should get the same proportion as J over K. All right, so we've got all of these. And, basically it's just kind of about balancing it. So if I take the upper segment and create a proportion between that and the actual length of the triangle side, the equality of that would be taking the upper segment on the other side and the measure of the other side and comparing that. Let's dive into practice here because I think you'll see what I mean. Okay, so let's say that you're given this picture and you're asked to find the missing length, which is right here. What I would do, I would keep this picture handy, maybe even print it out. And when you're just kind of getting used to the proportionalities, what I would do is label this picture in the same way that this one is labeled. So for me, um, this picture in white kind of looks like this one tipped over on its side. And what I mean by, like, if this is the top point of my triangle, if I kind of tilt my head, that corresponds to this point. Do you see what I mean? Because I've got this line segment would correspond to that line segment, right? So kind of tilt your head and see if you can picture that. So I'm going to label my line segments accordingly. So line segment A would then correspond to this line segment here. Line segment B would correspond to this line segment here. This guy would become C. This guy would become D. The length of AB would be J, and the length of CD would be K. So you can see I've associated all of my segments together, and here's why that's going to make it easy for me. I'm trying to figure out what D is, right? I'm trying to figure out what D is. So I'm going to say, okay, which one of these contains the letters that I know stuff about and the one that I want to know stuff about? So I know the value of K, or of C, excuse me. I know the value of C, I know the value of B, and actually, I know the value of A as well, right? Because by my segment addition property, if the full length of this triangle side is 14, and this segment is 4, then A must be equal to 10, right? Because 10 plus 4 is 14. So I know A, B, and C, and I know J, it looks like. And I want to know D. So I'm going to try to find a proportionality that involves some jumble of these letters, right? Pretty much K is the only thing that I'm trying to avoid because I don't know anything about it and I don't want to know anything about it. So let's see. I don't want to know anything about K, so that kind of eliminates all those. All right, what about this? What if we use AB over CD, or AB equals C over D? A over B equals C over D. This proportionality would work just fine too. I'm picking this one just because I saw it first. So here's what I mean by I'm going to use that proportionality. So if I'm given, I know that A over B equals C over D. I'm going to plug in what I know, and I'm going to try to solve for D. Okay? So I know that A is equal to 10 because I used my segment addition property to deduce that if the full length was 14 and that segment was 4, A must be equal to 10. So 10 over B is equal to 4 equals C, which is 15, over D, which I don't know. All right, so I've got 10 over 4 equals 15 over D. I'm going to simplify this. I'm going to divide out a 2, right? I know both 10 and 4 are divisible by 2, so this becomes 5 over 2. So 5 over 2 is equal to 15 over D. From here, I'm going to cross multiply. So 5D equals 30, D equals 6. Okay. So my answer for the missing length is that D equals 6. Now you could double check this, right? So I could just plug in and say, all right, does this satisfy? Is 10 over 4 equal to, let's see, C was 15 over 6. Well, let's simplify. That becomes 5 over 2. If I divide out a 3, 15 divided by 3 is 5. 6 divided by 3 is 2. So that did check out, and that's a great way to double check. So again, I took the information from here and I kind of applied it onto my picture, and then I selected the proportion that involved information about the side lengths that I did know and the line segment that I wanted to know. I excluded the segment that I didn't know and didn't care about. From there, I used cross multiplication to solve, and then I double checked by just plugging in my answer to make sure that I got a true statement when I plugged it in and solved. Let's do one more example with that. So here, once again, we're asked to find the missing length, which by that they mean 5x. So I need to find x, solve for x, so that I can figure out this true length of that side. Okay. But once again, I'm going to use that same technique I used before, associating, A, B, C, D, J, K to this triangle. So once again, if I'm going to think about this point as the top of my triangle, so I've got a point and then I've got that parallel line, to me that lines up with this point and this parallel line if I turn my head and look at it. So that means that this would be C, this would be D, right? A, B, and then this would be J, and this would be K. Be careful when you're doing this. It's really easy to make mistakes because you're kind of, trying to rotate the image in your head as you go back and forth. Very easy to get mixed up. So I know that A is equal to 20. I know that J is equal to 36. I know that K is equal to 45. I know that C is equal to 5x. Once again, I'm going to use the segment addition property. If I know that this measure of the full side is 36 and I know the measure of this line segment is 20, then I can deduce that B must equal 16 because 20 plus 16 is 36. Okay, but my goal is to figure out C. So I know K, I know A, I know B, and I know J, and I want to figure out C. So the only thing this excludes is D. I don't know what D is. I don't care about what D is. So I'm going to cross out, let's see, that has a D. I'm going to cross out any proportions that involve D. All right, and that leaves me with these two. And again, I'm going to pick this proportion just because it's the first one on the list. I could just as easily solve using that proportion. It doesn't really matter. Let's set this up. So I've got A over J equals C over K. And I'm going to plug in those numbers. So what have I got? I know that A is equal to 20. I know that J is equal to 36. I know that C is equal to 5x. And I know that K is equal to 45. Once again, I'm going to simplify to make my cross multiplication easier. So 20 and 36 are both divisible by 4, right? So if I divide 20 by 4, I get 5. If I would divide 36 by 4, I get 9. 5x and 45 are both divisible by 5. So if I divide 5 by 5, I get 1x. If I divide 45 by 5, I get 9. So from here, it's probably pretty evident that x must equal 5, but I could still cross multiply to double check, right? So that would give me 9x equals 45, and again, x must equal 5. So x must equal 5. I'm not done yet. Knowing x equals 5 doesn't tell me the length. If x equals 5, 5 times x is 25. So let's double check. Let's double check what's happening here. So I'm just going to replace my 5x here. So I'm going to rewrite this. I had 20 over 36 equals 5x. If x equals 5, again, I'm just going to replace that with 25 to double check my answer. Once again, I'm going to simplify. 20 divided by 4 is 5. 36 divided by 4 is 9. 25 divided by 5 is 5. 45 divided by 5 is 9. So I did get that 5 ninths equals 5 ninths, so the proportion did hold here. So again, when you're doing these problems, finding the missing lengths on using the triangle proportionality theorem, I recommend using that diagram that I have up there with that yellow background, matching up all the sides, calling them by the correct, A, B, C, D, at least until you get, maybe 5, 10 practice problems in, and then maybe you'll start to recognize the proportions without those labels. And then again, just be careful, double check. Very easy to just mislabel something and end up with a wrong answer. And the way to check for that is, of course, always to double check the solution that you get. So from here, guys, if you want credit for watching this recording, please be sure to go check out the corresponding quiz in Google Forms, and I will see you next week.